Be recorded. Hello, I'm Roland McDevitt. I'm the Division Chief for Paddlecraft Safety. And tonight we have Warren Darrell presenting on the topic of wind, waves, tides, and current. Warren is an Oxpad qualifier, which includes being an ACA instructor. He's a coastal kayaker down around Wilmington with a lot of opportunity to get into tides and current and everything we're talking about tonight. And he's got a lot of interest in kind of related topics, like he monitors things like king tides and things of that nature. So I think he's really very well positioned to talk on this topic. So Warren, I'm going to turn it over to you and take it away.
Okay, thank you, Roland, and thank you everybody for being here. And when we show the slides, in addition to what I said about questions, when let's see, let me make sure we get this on share. There you go. I think everybody should right now be seeing the presentation. When you see a lot of words, a lot of times I'm not going to read you every word because everybody can read. So sometimes I'm just going to go to the next screen and you can read the words and then we'll talk about them, or I'll speak for emphasis. So is there anybody who cannot see a picture of a kayaker? Okay, I'll take that as an affirmative that everybody can see the presentation. So we're going to go ahead and get started. Okay, this could help us. This information could just have better paddling experiences and be safer and fulfill our mission to teach other people safety. Okay, so no, a lawyer did not write this. I wrote this, but it's true. We can't cover everything. You know, these things are very complex. They're interactive. They're not the same in the same place or the same time anywhere. And so there's no way we can cover everything that you would need to know, but the principles hold pretty much everywhere. And then you learn through experience and study how to apply those principles. So this is kind of my disclaimer of like, you know, you didn't tell me that I could get stuck in a low tide or, you know, something like that, right? Okay, why do we need to know about wind? We're going to start with wind. Well, why do we need to know? Well, there's one reason. Wind does this to the water. And if it's going to do this, we probably don't want to be paddling in that. This looks like New England to me. Now, wind can do a lot in the water. And this is about a 1979 race off the coast of England, sailboat race. 15 yachtsmen died in a force 10, which is not a hurricane. So this is why we need to know about wind. You need to know about wind for safety purposes. And if anybody wants to actually read a great sea story, this is a good book to read. So we've probably all seen these flags that can fly at, you know, marinas, yacht clubs. I don't know if I haven't seen them fly at our Coast Guard station, but this is your standard signals to tell you what the wind is doing. And we're not supposed to go out, and even in our power boats and even a small craft advisory, if it's in the area that we're going to be patrolling in. So my rules of the wind are, if there's a small craft advisory, you could paddle in it if you are, I'm going to say, an advanced paddler. 20 knots is a lot of wind. Exerts a lot of force both on you, your boat, and on the water. And as far as I'm concerned, don't go. If you see this much flags, don't go. You really don't want to be out there in a 40-knot wind. At least I don't. Okay, wind direction. The winds are named for the directions they come from. For example, a north wind blows from the north and an east wind blows from the east. Now, some people think because that came up because if the wind is, let's say, coming from the east, and let's say there was land here, but you couldn't see it, the sailors might be able to smell the land because it's blowing the wind, taking the air from the land to the boat. I don't know if that's the case, but the winds are named for the directions they come from, which is the opposite of how currents are named. So I guess that was developed in order to confuse people. And, I don't think that we ever have to say, oh, the wind is coming from, a bearing of 64 degrees. I mean, I just say, usually if you check the weather reports or you look at the water, you look at the wind, it's coming from the northeast, it's coming from the west. That's usually close enough. The 8 points of the compass are usually accurate enough in terms of knowing what direction the wind is coming from. Now, a land breeze versus a sea breeze. Well, a land breeze comes from the land and a sea breeze comes from the sea. So what a lot of times in the summer, especially in the summer, later in the day, you'll have a sea breeze because the sun heats up the land, the air gets heated, it becomes less dense when it's warm, it rises, and the cooler ocean breeze comes in to replace that air. So it's a sea breeze if it comes from the sea. It's a land breeze if it comes from the land, and it comes, and the opposite could happen. The land could cool off. The water, which has a lot of what we call thermal inertia, stays relatively warm. So this air tends to rise, the land air tends to fall. So you'll get a land breeze coming from the land. Okay, so there's the Beaufort scale. I'm pretty sure there was an admiral or somebody named Beaufort. And Fastnet Force 10, that book we looked at, Force 10, Beaufort number 10. So they're talking about 55 to 63 miles an hour. It's called the whole gale. So it wasn't a hurricane that killed all those expert yachtsmen off the coast of England. But you can Google this and you can get actually photographs of the ocean at the different Beaufort scale winds. And, but the bottom line is, is you kind of realize that as the wind speed picks up, its effects become stronger on both land and sea. And, we have a different name for them now. Even what they call a fresh breeze is a 20-mile-an-hour wind. So now we're getting a significant wind. And they're still, oh, yeah, that's just a fresh breeze. A strong breeze, 30-mile-an-hour wind. Well, I don't know. I mean, out paddling in a 30-mile-an-hour wind would be pretty darn challenging. So, the names are a little bit, when you get to fresh gale, you're talking about some serious stuff. But anyway, that's the Beaufort scale. So, but the much more famous Warren's kayaking wind scale. Here we go. This is my wind scale. Okay, let's say you're a beginner kayaker. Well, if it's 0 to 5 knots, which is, as we know, 5 knots is a little bit more, is 15, about a little more than 5 miles an hour. It's about 6 miles an hour. A beginner, really, it's very little impact. Once you get above 5, for a ranked beginner, start work your way up to it. Go out in a 5 or 6 mile an hour wind, see how you handle it before you start getting up towards 10. If above 10, I would say you need to start to get to about intermediate level skills. And if you're a beginner and it's 20, don't go. And intermediate, okay, you're kind of one level above that. But when it starts to get above 10, now 10 is not too bad, but you got to take it into account for trip planning. You may not want to paddle against a 15-mile-an-hour wind on your way home. Just kind of work your way up to 15, 20, work your way up. If you're an advanced paddler, you don't need to hear me talk about it. But this is, I think, a good reference because people can tend to underestimate the effect of the wind, and the wind gets stronger typically in the afternoon as the land heats up. And now you go out in this and you're up to here. And if you're really a beginner, you may find things a little too challenging. Okay, so wind. The effect of wind on the water, there's a lot of things that affect it, but the three main things are speed, fetch, and duration. Speed is obviously how fast is the wind going. Fetch is what's the distance over which the wind can blow. And you'll see some pictures that'll make that more clear shortly. And the duration is how long has it been blowing? So if the wind is strong, it has a long distance of many miles over which it can blow unimpeded over the water, and it's been doing it for a full day or 2 days, it can have a pretty big effect on the water. Whereas if it's just started or if it's shielded by land, then it doesn't have as big an effect on the water. So one thing they don't mention is that in addition to pushing your boat and generating waves, the wind also creates a current on the surface of the water. Now that current typically is often not very deep. Now sometimes it can be if there's no other currents going on and wind blows for a long time, but especially in a kayak, a light vessel that is much affected by the top 2-3 inches of water, that wind-driven current also pushes your boat in the direction of the wind. So it's kind of like a double whammy. The wind is pushing your boat, the wind is pushing against you, and the wind is moving the water. Now, for example, this is the lake where I used to go as a kid. And sometimes in the afternoon, this lake is almost 3 miles long. This is Crescent Lake, Maine, one of the most beautiful places on earth. And the wind typically, a lot of times, will start coming from the north in the afternoon. And so if you're down at this end of the lake, which we typically were here and here, the wind would have a long fetch. And I was out once in really a ratty sailboat that I was just a kid that couldn't sail worth a darn against the wind. And between the wind and the wind was pushing the water in this direction, I could make no progress. I would tack, and I got nowhere. And I ended up having to go to land and walk the boat on land, which was also pretty hard. So wind shadow. This is a picture of close to where I am, the Cape Fear River. This is the Intracoastal Waterway. The ocean's over here to our left. So what a wind shadow is, you can see the spoil islands where the Corps of Engineers has been dumping the dredge material that for decades that they dredge out to keep the ICW at depth. And then, you know, trees and stuff end up growing here. These are not natural islands by and large. And the trees and stuff that grow there have just kind of naturally sprung up over the decades because, you know, birds and critters and the wind brings seeds out there. But this created a wind shadow. So if the wind is coming from the sea, meaning a sea breeze, which is typical in the afternoon, that these trees could shade the wind. And so when you're on the lee side, when the wind is hitting the island, you don't get that strong a wind. However, beware of turbulence and the funnel effect. If you're here, I mean, you could be cruising along. Let's say you're going this way, and you got a nice wind shadow going on. You know, you don't feel a very strong wind. Then you get to here, well, the wind can kind of funnel in between because it builds up pressure when it hits these trees, pressure for it. So suddenly you're into a much stronger wind. And that can happen, and you need to be aware of that in a paddlecraft, which is much influenced by the wind. And also there could be turbulence. Sometimes the wind swirls around when it goes around corners. But the wind shadow is something you want to use to your advantage. For instance, let's say the wind is coming like this way and you want to go that way. You say, well, I'm going to get close to this shore so that for most of the time I've got the wind shadow blocking the wind because it's coming sort of against me. Now, let's say the wind is blowing in this direction. Now you have a long fetch. This is roughly to the south, going this way, or to the southwest. So the ICW can actually get kind of rough when the wind is either coming from the northeast or coming from the southwest. This would be a northeast wind because it's coming from the northeast. And it could actually get rough, and depending on what the tide is doing, it can drive a surface current along with the wind. We'll talk about that, and that could create a situation where you really don't want to lose control of your boat, which we'll talk about. Okay, what do we mean when we talk about a lee shore? Well, lee means downwind. Now, why? I have no idea. So that's a lee shore. So obviously, things could happen on a lee shore that you don't want to have happen, like what's happened to this sailboat. It's blown onto a lee shore, a downwind shore. Now, on the other hand, here, this sailboat is in the lee of this land, meaning it's downwind from the land, so it's got a wind shadow. Now, there could still be turbulence and wind funnel effects, but generally, the lee shore, I mean, if you're in the lee of a windward shore, you've got calm conditions. But if you've got a wind blowing you strong into a lee shore, you often do not have conditions as calm as this picture. It can be a lot rougher than that, and you don't want to get banged up against that shore. Okay, so here's what we were talking about. Now, this is your person doing your basic paddle float recovery, although usually when I'm connecting the paddle float or doing anything, I will keep the kayak turned over but you can hook your leg better in it when the kayak is upside down. After you get yourself arranged, then you'll right the kayak. But the reason I say hold on to your boat is this. In the first place, you're probably not going to be doing this in calm water unless you're practicing. If you need to do it, it's probably because the water's rough and windy. Well, let's just say that the current is going that way, maybe because of the tide, but the wind is going that way. If you let go of that boat, you are going to go with the current because your body is mostly in the water and the water is going to take your body, but the wind is going to blow the boat because the boat's floating right on the surface of the water. It's not that affected by the current, but it's very much affected by the wind. And if the current and the wind are going in different directions, and they don't have to be opposite, it can be like 90 degrees, you and your boat become very separated very quickly. And this only happened to me once, and it's not a very pleasant experience because you cannot, I don't care, you could paddle swim, you could do whatever you want. You cannot catch up with your boat when the wind is pushing it one way, if it's any significant wind, and doubly so if the current is taking you in a different direction. Hold on to your boat. And by the way, as I discovered that one time, I was just practicing my paddle float stuff, just so I could go out and practice. And once you put the paddle float on the paddle, the whole paddle swim thing doesn't work so well. Okay, so before we go on to tides, does anybody have any questions about what we've covered about the wind?
I don't see any questions in chat.
Okay, well, we're going to go on to tides then. Okay, why do you need to know about tides? And here where I am, we have typically about a 4-foot tide range. It could go up to 6 feet depending on conditions. In places like New England, they have greater tide ranges. Parts of the West Coast do. It all depends where you are. Okay, so I don't need to worry about chat. So why do you need to worry about tides? Well, here's a couple reasons. First, this is actually a tidal current. This is not a river. This is a straight in the ocean or on the bays of British Columbia. That is a tidal current. Do you think you could paddle against that current? Maybe not. So you need to know because the tidal currents, which are a result of your tides, can affect which direction can you paddle in and when. Like maybe you're going to say, well, if we got to go this way, we better do it while the tide is in our favor, or the other way too. So it affects the currents, which affect, can we do this? Like you really don't want to go on a paddling trip. And then when you're on your way home in the afternoon, you're paddling against both the tidal current and the wind. It can make for a, less than ideal way to end the day. And the other reason you want to know about tides is, am I going to have enough water? Been there, done this, okay? Slugging my boat through the marsh mud, and it is a lot less fun than it sounds like. And this can happen. A lot of the stuff I say is because I learned it the wrong way. And you could paddle into an area when the tide is somewhat high. Tide falls, now you can't get out, or this is how you get out. It's not that great. So, am I going to have enough water? And what are the currents doing? That's primarily why we need to know about tides. Now, the primary body is the moon. The sun has an influence. And since the moon and the sun, their positions and the earth can be predicted well in advance with great precision by people smarter than I am, the tides can be pretty well predicted in advance. However, they're also affected by ocean currents and the weather, by wind that can't be predicted very well far in advance. So the tides approximately are known well in advance, but there are always influences that are not predictable, at least not to your normal tidal predictions and sources of weather. So you don't really need to memorize all this, but the gravity of the sun and the gravity of the moon. Now, yeah, the moon is a lot smaller, so its gravity is weaker than that of the sun, but the sun is like, this is not the scale. The sun is like way, 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 way far away. The sun is 93 million miles away. The moon is 250,000 miles away. So the fact the moon is closer, even though it's small, it exerts a greater gravitational influence than the sun does. But in addition to their gravity, the moon and the earth are actually rotating around each other. And so that inertia creates the bulge on the opposite side of the moon. But you don't really need to know that. What we need to know is it's the sun and the moon, their position relative to the earth, that affects ocean tides and currents. But the other thing that matters is how far is the moon from the earth and how far is the earth from the sun, because the orbits are not perfectly circular. So sometimes the moon is closer to the earth than other times, and ditto-wise, the earth can be closer to the sun. And that affects the strength of the tide, because the closer you are, the stronger the force of gravity, the more it pulls the water of the earth's ocean. Okay, that's a tidal current. They can be pretty strong. Do you want to paddle upstream against that? What does that say? Oh, yeah. Sometimes the tidal currents are faster. I mean, I've been in inlets here in North Carolina where, like, you're paddling gangbusters and you're going nowhere because the inlets tend to funnel the tides, as we'll see, and you can't make any progress. In fact, you might be going backwards. Now, that can really matter. Let's say that this tide is headed out towards the ocean and you don't want to go out to the ocean. We need to know about tides. For example, I believe this is Mason's Inlet. Here's the Intracoastal Waterway again. This is Wrightsville Beach Island. And so this inlet, you could see now, as I'm going to say later, if you were in your kayak here, these waves would look a lot bigger than they do in this picture. And you don't want to be, if the current is too strong, you don't want to lead your group. And I made the mistake once of taking somebody, it was my mistake, 100% my error. I took a guy out in an inlet and he could not handle the tidal current. So if that current is taking you out to the ocean and you really don't want to end up go into the surf zone, you don't want to be there. So you need to know, is the tide rising or falling? What do the tidal currents do? And you know that by learning these principles, applying them, and then observing and getting local knowledge, because it's nature and it's complex and it's a little messy and nothing is completely neat, but these concepts generally apply, but they vary in depending where you are. So these inlets are where tide makes a big difference, which is also, by the way, a lot of times, you know how you get shallow water like outside of your inlets? It's because the tidal currents take sand, you know, they're constantly eroding all over the place. And when they carry that stuff out, and then out here, you got the ocean, so the water kind of spreads out, it slows down, and that sand sediment falls. And that's why you tend to get what they call ebb tide deltas, shallow water outside of inlets, which we'll see a little bit more of later. For example, there you go. That's what tide range means. It's the difference between high tide and low tide. Now, they're not always the same. You know, low tide varies over time and place. High tide is not always the same. So the tidal range can be different one day. In fact, usually is different one day from the next. But there's usually an average tidal range for where you are. Like where I am, usually high tide, low tide, it's usually about 4 feet. And it takes 6 hours to make that change. So if you look at the average, that's 8 inches per hour. It's kind of good to know that stuff for the area that you're in. Doesn't mean it's flooding anything, that's just a word we use. When it's at high tide, we call it flood tide. Or they may refer to flood tide if the tide is coming in. And an ebb tide or an ebbing tide is a tide that's going out. And when the tide is low, it's called ebb tide, like the song, ebb tide. So we're going to look at how you know when this is happening a little later. But usually when it's high tide, you know, flood tide, it's as high as it's going to get. Usually for about an hour or so before that and after that, the tidal currents are usually not that great. Now, that's not always the case. Tidal currents are complex, but usually the water level doesn't change very rapidly when you're right at high tide. And similarly, when you're at low tide, the water level doesn't change rapidly, usually for about an hour before low tide, an hour after low tide or ebb tide. But when the tide is rising or falling, usually when it's about halfway between high and low, that's when it's at its fastest rate of change. And often when the tidal currents will also be at their fastest rate. Now that's not precise, as I keep saying, this stuff is messy, but it's kind of a general principle. So since the tide cycle is about 6 hours and 15 minutes long, and it's not always the same everywhere, but it's usually about that. So about 3 hours, let's say after low tide, the tide is rising as quickly as it's going to rise. And about 3 hours after high tide, the tide is falling about as rapidly as it's going to fall. So here's your typical tide chart. I use U.S. harbors. There's about, dozens of sources for this, but U.S. harbors I find to be very good. So typical for June of this year, this Wrightsville Beach, there you go, gives you the time and the depth of high tide. Now you can see the depth changes. Like here, you've got a high tide of 4.7 feet above mean low water, I think it is, the datum. And here, 5 feet above, and then other times the high tide is not as high. And then it tells you the time of low tide. Tide, you can see, can be lower than mean low water. So sometimes the water is even lower than what shows on the NOAA charts. Gives you the time, rising and setting of the sun, but also gives you the phase of the moon. Because look, at a new moon means no moon. You could see the tidal ranges are pretty great. Look, we got 5.2, 5.3 high tide. At a half moon, we have 4.2, 4.2. We have less high tide. Similarly, the lows are lower during either a new moon is no moon, or a full moon, which doesn't quite make it on this little snippet that I showed here of the tide chart. I find U.S. harbors to be good, but you find your own sources. I'm not recommending anything in particular. So when you have a full moon or a new moon, we call them spring tides. Has absolutely nothing to do with the spring season of the year. During a half moon, so a lot of times it is good to know this, even on our powerboat patrols. I usually like to know, well, it's a full moon or it's a new moon. We're probably going to have pretty strong tidal currents because we're going to have a big tide range. We're going to know that the shallow water is really shallow during a full moon or a new moon. And during a half moon, not so much. So it's kind of good to know the phase of the moon because it affects the tide, which affects the depth of the water, and it affects the strength of the currents. For instance, king tides, we won't go into this in great detail. There are times here it's shown in orange, so they're kind of very irregular, but they can be predicted in advance. They happen when this stuff happens, and then you get even higher high tides and even lower low tides, to the extent sometimes it'll flood land that is not normally flooded. For instance, this is Carolina Beach. Does it look like it's raining? Negative. There's no rivers anywhere around here. This is just a spit of land. The ocean's off here to the right. This is the boat basin, and it connects with Carolina Beach Inlet right about up here. And this is simply the ocean getting deep enough to flood Canal Drive. There's no storm, obviously. This is not a hurricane. This is not a nor'easter. This is not rain. This is tides. So diurnal tide, one high tide, one low tide a day. Semi-diurnal, which is what we usually have, 2 highs, 2 lows a day that are roughly equal. And a mixed tide has unequal highs and lows. For instance, the Gulf Coast is generally diurnal or semi-diurnal. You'll have 1 high tide a day, or 2 if it's semi-diurnal. I guess it looks like semi-diurnal at Mobile, Alabama. We don't need to go into this great detail. Boothbay, Maine, for one thing, notice here at Boothbay, Maine, the tide goes from 9 feet down to almost 0, less than 1 foot. Here in Mobile, it goes from about 0.5 feet, half a foot, 6 inches, up to about 1.2 feet, 15 inches or so. So, here you have a much smaller tide range and probably weaker tidal currents than you do up in Boothbay Harbor, Maine. There's a lot of variables that determine that. But here we go. So a diurnal tide has a high tide once a day and a low tide once a day. It's not exact because the tide cycle is slightly longer than 12 hours, but it's pretty close. Semi-diurnal, what we have here, 2 high tides that are pretty close to each other and 2 low tides that are pretty close to each other. And mean low water would be the average over a long period of time of these low tides because they're not all the same. And a mixed semi-diurnal, which they have a lot on the Pacific coast, you have 2 highs and 2 lows, but they're quite a bit different. The highs are not equal to each other and the lows are not equal to each other. It's good to know what you have in your area. Now, we're starting to get into a little complicated stuff, but you kind of need to know this. Generally, what they call a tide station, nobody's measuring the tide. Now, some of them they are, but a lot of them it's just a calculation. And so if you go to your friendly source of tidal information, usually you could find the position of the tide station where it's either measured or calculated. In this case, it's calculated. And they call it Wilmington Beach, even though this is Carolina Beach. This, by the way, is where that road was flooded, right in here. No, it was right in here, Canal Drive. And so this is the point it's calculated from, but I happen to live up here and usually launch here and go out this inlet or screw around in here, do something. And so I want to know what the tide is doing here. So we won't go into all the details, but it's good to be able to estimate, well, if the tide is going to be high at 3 p.m., let's just say here, what time is it going to be high here? And we won't go into all that, but we know that the tide here and here is probably roughly equal because it's just ocean. There's nothing in between to block the flow of water. So I figure, okay, if it's going to be high at 3 o'clock here, it's probably going to be high at 3 o'clock here. Now, you have to gain this with a little experience. It takes the tide maybe 30 or 40 minutes to travel here. So my tide is usually 30, 40 or 40 minutes lower than later, and my low tide than the tide at the tide table where I'm looking at it to see what time is high tide going to occur. So this is not just like esoteric detail, because this affects your planning. This affects those two variables. How much water are we going to have and when are we going to have it? And when are the currents going to be strong and in what direction? So you have to kind of be able to adjust for the difference between the place that your tides are calculated for and where are you going to be paddling. Now, let me see here. Roland, do we have anything of great interest in the chat?
We do. We have a question from Holly Dillard, and she's asking, how large does a body of water need to be to have tides? Is it only the ocean, or do the Great Lakes also have tides?
I believe the Great Lakes have small tides, and I understand that the lakes in New Zealand, which are a lot smaller than our Great Lakes, also have measurable tides. So the answer to your question is, I believe they're of significance only in the ocean, but yes, smaller bodies of water do have tides, but they may not be enough to affect your boating. Well, got any others?
Are there any other questions that people want to shout out?
Okay, we're going to keep going.
Okay.
Ta-da. So this is kind of talking about what I just said. So this usually is about 1 hour. But I said 1 hour, it could be half an hour, 40 minutes, 1 hour, it depends, later than when I'm looking at the tide table. Okay, now this is what Roland was talking about when he said that you don't have really big tide ranges and the places where y'all paddle on the Outer Banks because you don't have many inlets. So the ocean out here, this Oregon Inlet, so I believe Kitty Hawk is up here somewhere. The tide's about 3 feet, which is not ginormous, but it's significant. But you only have this one little inlet. I mean, it's a pretty big inlet if you're paddling in it, but compared to all this water in the sounds, this is very small. So the tide doesn't have time to get in here and change this water very much because it takes a huge quantity of water to raise and lower the water level here, a huge flow. And there's not that much time for it to go through this relatively small inlet, meaning it's small relative to the volume of water that is affected by that inlet. So you typically have not much tidal range and not much change in depth in the sounds of the Outer Banks. Now, on the other hand, when the sun and the moon, and the earth change positions relative to each other, and now let's say you got a lot of water in here, even though it might only be a foot higher than the low water, it's all trying to get out this little inlet. The ocean is falling 3 feet, and so you can get a pretty fast current going through that inlet. Even though you don't have a big tide range here, you have a bigger range out here. And when you're in a place like parts of New England or Maine and other places where they have big 10, 12 more foot tidal ranges, the tidal currents can really be fast. So sometimes, okay, let's say you don't know what the tide is doing. You might be in a strange place or whatever. You try to get some clues. Well, what's the tide doing? For example, this is right here where I paddle. If you see oysters, well, obviously we're not at high tide. These oysters wouldn't be there. They need water. Usually oysters are such that they're covered by a little bit of water, a couple inches anyway, at high tide. And some of them are always submerged, but all of them are submerged some of the time or they wouldn't be alive anymore. And you can see the tide probably goes up to here. Sometimes you can see marks on the vegetation. So even if this was strange, you say, we're either at low tide or maybe we're at mid tide. You kind of look around. So you've got some clue as to what the tide is doing. There could be marks on docks. You just look for clues. What's the tide do here? Now you look for clues as to the tidal current. Now you can actually tell. Okay, this is a quiz. There's your quiz. You have all the information you need here. You don't need to worry about that. Just this picture right here. Is this tide rising or falling? If you got the answer, chime in. This is not a trick question.
I'd say rising.
Why?
Oh, wait, no. Well, I first thought it was rising because it was going against the buoy, but then I realized that's probably the horizon, which is further out, so it would be lowering because of the flow.
How do you know that?
Inflow and outflow.
Okay, I'm going to jump
The
in
buoy
here.
is tilted.
You have all the information you need, and here's how you have it. Red right returning. That's a red buoy. So if you were returning from the sea, that buoy would be on your right. I'm just aimed at it in my kayak so I can take a picture of it. So you would be going this way. The buoy would be on your right if you were returning from the sea, from the ocean. So the ocean is out here. The water is flowing that way. So if the water is flowing from the bay, let's say, inland out to the ocean, the tide is falling. So you look around to get clues. What's the tide doing? Because remember, you need to know about that to make sure you have enough water and that you don't get stuck in a current that's too fast to paddle against. Now, this looks like, somewhat of a significant current, but this is probably a knot or so. You could paddle against it. But on the other hand, if you normally paddle at 3 knots, now you're going at 2 net speed over ground if you're going directly against it. And if you just lollygag and do nothing, it'll take you out into the ocean. So that's how we know red right returning. That means if we were returning, we go this way, the buoy would be on our right, the ocean's out here. Okay, so we got a lot of currents. Now we're getting on to currents. So currents and tides are obviously related. So before we go to currents, any questions about tides? Okay.
Any questions? We had a comment from Charles. He said virtually any body of water is affected by tides. The larger the body, the more effect it has. It's also affected by the latitude and longitude. Some tides over in Europe have more than 30 feet difference between high and low. And the Bay of Fundy in Nova Scotia has a tidal range of 50 feet.
Right, which is up here. And it's affected by latitude and longitude, but actually also by underwater topography, the slope and distance of the continental shelf, because there are places near the equator that also have big tides. So it's affected by latitude, longitude, the rotation of the earth, blah, 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 all that stuff. And up here, they do have tremendously strong tidal currents because there's so much water that changes place up in the Bay of Fundy. It's pretty famous. And that's true, right? Bodies of water, I guess theoretically you could probably have a tide in your bathtub, but in terms of significance to navigation, usually I think things that are connected to the ocean, Great Lakes, maybe. I doubt that it's significant to navigation, but I don't really know that. Okay, so you have currents in the ocean that are driven by the rotation of the earth and temperature and wind. We don't really worry that much about them because you're probably not kayaking out here. So, but they're there, they exist, those are currents. So we're gonna cover the type of currents that we normally encounter when we're paddling in the near shore and inshore environment. And by the way, cold currents, because they come from a polar area, you can see this is why it's always cold in California in the water. Even in San Diego near the Mexican border in the middle of summer, the water's still cold, and it's because they've got a current coming from the north. Ditto wise Maine and New England, why the water's always cold up there. Okay, so for example, out here in the ocean, don't worry about tidal currents. But let's just say you had a simplified version. of an inlet, a bay, and then maybe a river going from that, which is kind of typical your East Coast. On an ebb current, meaning the tide is falling, which was in that picture we looked at, this water is falling, so this water is flowing out this way, and the tidal ebb current goes out this way. On a flood current, this water is rising, so the water is flowing in to the land, and it could go a considerable distance up a river. Now, it doesn't always go exactly in sync with the time of the tide. Like you would think, let's just say at flood tide, when this water is as high as it gets and it's not changing, because remember, it doesn't change very fast when it's at its flood. You think, well, the current should be zero. Well, yeah, that'd be logical, but it's often not true. The currents are complex and they're not always exactly in sync with the time of the tides. And I don't really think I can tell you much more than that because I don't know much more than that. And the wind is a big factor, at least here, and I'm sure along the whole North Carolina coast and probably around the world. I mean, if the wind is blowing strongly onshore, it can raise the water level a foot or more, depending how long it blows and how strong it is and your underwater topography and a lot of other things. But wind can be a factor in the depth of water and thus influence the tide range and the currents. Okay, this is Masonboro Inlet. The Wrightsville Beach Coast Guard Station is right here. This is the town of Wrightsville Beach, or the city of Wrightsville Beach, the marsh, the Intracoastal Waterway. The other stuff we looked at was down here farther south. Remember, I said this goes roughly northeast to southwest, more or less. This, you can see the jetties. This is a well-dredged, well-maintained inlet with stone jetties. So it's fairly deep and wide, and it conveys a lot of water. Because it's deep and wide, well dredged, a lot of water goes in and out of this inlet. So if the tide is rising, that water is going to tend to do this, what these red arrows show. And it'll do the opposite when the tide is falling, although not always in exact sync for time. But this is what you need to know when you're paddling. And you gain this through studying your charts or your Google Earth images, your tide tables, and then just observing with experience, because this can affect your trip planning. Let's say you launch somewhere in the town of Wrightsville Beach. You don't want to be doing this or fighting this if this was reversed on a falling tide on the way home usually. So you kind of use this for trip planning, both for what the current is going to do. And let's say you're going to go back here into Bradley Creek. Well, am I going to have enough water? So, you kind of want to try to figure out, how is the tide going to affect the water where I am? Now, I'll talk about this in a second because there's another picture that I could talk to about this from experience. But it's also kind of funny that you could, especially when you're like in the shallower areas in a marsh, you could actually have a wind. Like, let's say you were in here and the tide was rising and doing this, but let's say the wind was going the other way, like that. You could actually have a situation where the surface water is being driven by the wind, which is maybe your boat, because a kayak is driven a lot by the wind. It's right on the surface, but the deeper water is going the other way. And sometimes you can look in the vegetation, and I have seen this where you can see stuff on the surface is floating one way, but the submerged rooted vegetation, which, kind of, you can see which way the water's going down deeper, is going the other way. Just good to know for trip planning purposes. And kind of what we talked about getting separated from your boat. When they're doing that, it's easy to get separated from your boat. And it's just good to know, what are the currents? I mean, if you're docking a boat, just power boating, whatever, it's good to know what the currents and tides are doing. Okay, let's talk about rip currents. Now this is a rip current. You can tell, you can usually, not usually, you can often spot a rip current by the discolored water, because sometimes it's carrying sand or sediment in it, sometimes by the foam pattern, but usually the real, and you can see how it's flowing out into the ocean. And really the telltale thing is it usually is actually calmer in the rip current. It, for whatever the reason, it kind of mitigates the waves. It sort of knocks the waves down somewhat, and it's calmer. It's strange because people know, well, they're dangerous, which they are, but it's actually calmer usually in a rip current. Now, this can be your friend actually as a kayaker, because let's say you want to launch from this beach. You want to launch in the rip current because the waves are smaller and the current is going to help carry you out past the break. Now, if you're swimming, maybe not so much, but that's how you could often spot a rip current, is by a break in the wave pattern and by a discoloration. And also they tend to, you don't see it here, they will tend to form, if you see the waves in cusps, you know, like that, shaped like this on the beach, sort of the break, then the rips are like where the water has got to flow back out to the ocean. So if you see a lot of cusps in the pattern of the waves breaking on the beach, usually that means there are rip currents. And I remember that in Santa Cruz, California. And I know Rowan spent time in Santa Barbara. I don't know if it happens down there, but you would see cusps on the beach and have really powerful rip currents. So rip current could be your friend or not so much. Another type of current, this matters, is the longshore current. Now, this could be due to a major ocean current. It can be due to the wind driving the water in that direction. It could be due to like these waves coming in, they refract a little bit towards the beach, but they're kind of driving the water towards the right in this picture. Why is this important? Well, let's say you're launching your kayak, right? Well, we know that if you're doing a surf launch, and you know, surf launch can be even in 1 foot waves, 2 foot waves. A surf launch can take a lot of energy, and you kind of want to do it right. That you know you want to launch directly into the waves. Well, the trouble is you've also got a longshore current. So it's pushing the bow of your boat that way. So what happens is if you orient your boat directly into these waves, by the time you get into enough water to paddle, the longshore current has probably pushed your bow that way. Now the waves are hitting the side of the boat. That's not what you want. It may drive you back up onto the beach. So you have to adjust your angle of attack to compensate for the longshore current. And I don't know of any system other than guessing, because how much do I adjust? I don't know. You just do it. And to the best judgment you can, and hope you've done it correctly. But it will push the bow of your boat. It will also, once you're out here, it will move your boat. So it's good to know if there's a longshore current going on, because for one thing, there may be something over here that you really don't want to get into, like the open ocean and breaking big surf or who knows what. So longshore currents, they matter. And they can be formed just from the waves, from the wind, from the tide, or from a larger ocean current. Okay, why do we need to know about waves? So before we get into waves, does anybody have anything they'd like to say about current, or ask or whatever about currents? Roland, if you, is there anything in the chat of interest?
Pat Johnson was just asking, how do you know if there's a longshore current? Can you recognize it by looking at the water?
Yeah, you try to look at the water and the beach. Usually, like where we are, Pat, usually where you'll see them is like Carolina Beach Inlet, or right on the beach itself. Like if you were on the beach, Carolina Beach or whatever, Curie, you could usually see it. You could see the general trend of foam moving or whatever's in the water moving in one direction. So usually you can see it. So that's how. Thank you for your question.
Another question from Patty. Any more advice on paddle offshore away from inlets, rivers, etc.? So I guess
Well,
the question is like getting away
yeah,
from shore. What are some of the things we need to be thinking about?
yeah, I'm going to punt on that one because I do have a good slide coming up that addresses that question.
Okay.
So we'll get to that. Any others?
I don't see any others.
Okay, so we'll keep going. Why do you need to know about waves? Let me see if this is going to do what I want it to do. Yeah, there you go. Been there, done that. This is one reason you need to know about waves. And take my word for it. If you get turned over in the surf zone, unless you're an expert roller like Roland is, you have about as much control as an ant in a washing machine. And this is you down here. Okay, you want to know about waves. So that's a surf launch like we were talking about in the previous slide. So one, you don't want to capsize. Two, you're probably going to end up at some point launching in the surf. So it's good to know something about waves so you can hopefully successfully launch in the surf. And it's amazing, as I said, how much bigger these waves are when you get close to them. And usually, people say, well, the waves come in sets. So you wait until you have a quiet set. Well, that's true, except by the time you recognize that the set is quiet, now it's been a while because you don't know it on the first wave. You know it, oh, look, I've had 3 or 4 small waves in a row. Now that quiet set is halfway over. So by the time you launch and get out there, the little waves are done and now the big waves are coming. So you want to know everything you can about waves. So basically, we don't need to memorize all these numbers, but you have deep water waves. This is a wavelength between crests. If the water's really deep, it's a deep water wave. If the water's shallow, it's a shallow water wave. You don't really need to worry that much about it. The thing you want to know is that the waves break when the water gets shallow. They get bigger, they get higher when the water gets shallow because it slows the bottom down, but the top keeps going. And so they get higher and then they eventually will break. And that's where stuff happens. So you could be out here and it's nice and quiet and like, yeah, this is not a problem. But you get down into the surf zone and things are different. Now, this is waves out on the open ocean. This is pretty big. I mean, we probably don't want to be paddling in this. And, but what it shows you is, yeah, these diagrams are idealized, but in the real world, you can't, there's like, a dozen different wave directions going on all at once. All the stuff is happening at once. And so the knowledge is good, it helps, but it's never in the real world as idealized as it is in the diagrams that explain this stuff. Okay, this is swell. This is what's called ocean swell. So the surfers, they love this stuff. Okay, so do kayakers. This is ocean swell. It's usually fairly gentle. This is pretty big swell. Well, you can read about it. So when it's in deep water, it's not that much big a deal. But then as it gets shallower, it starts to build up like this. And when it gets shallower still, it breaks. But when it's not breaking, you could do this pretty well. It's not breaking. So this kayaker's got a nice smooth ride down here. And this is swell. Now this is a plunging wave. This wave has now gotten into shallower water. This was probably swell out in the ocean, and it is plunging. It is breaking. It has a curl. This is like pretty advanced stuff going on here. A lot of energy happening in this wave. You'll notice he's wearing a helmet. He's not wearing a PFT. Okay, this is a spilling wave. It's not plunging like this. It's just kind of like the top is spilling over on itself. These are usually not too bad. You could usually paddle against these fairly well, and you can usually paddle with them fairly well. Now, you generally speaking want to orient your boat straight into the wave or straight with the wave, which is not that easy. But The spilling wave is usually not too bad, but you'll notice you got all different, there's a little plunge going on there. There's a lot of different stuff happening at once, and time and distance, where you are and when you're there changes everything. So you never want to say, oh, there's a spilling wave, I'll go out in that, unless you're really ready, because it might be plunging by the time you get there. But anyway, that's a spilling wave, plunging wave. Now, breaking waves, what happens? You can see the waves out here. The water itself is not really going anywhere. It just kind of circles around and goes up and down in one spot when you're in deep water. Now, when you get into shallower water, the waves get taller. Eventually they break, and now there is water moving. Now there is actually, the water is not just rotating up and going up and down in one spot. It's actually translating, moving its location, coming into shore. That's why you see water rush up shore. Well, that water's got to get back, and it rushes back usually low, deeper, and moves towards the shore on the upper surface. That's where the phrase undertow comes from. So anyway, it breaks in shallow water. The point is that out here, you may not even notice that there's waves, but you get into shallow water and those waves get bigger and they break. And even boat waves, significant, especially significantly sized boat, which might seem like nothing out in deep water 10 or 12 feet or more deep. You get into 2 and 3 feet of water, even a large boat wake can do you some damage. So there's a difference. If you see waves breaking, that usually means they're shallow water. Now, the bigger the wave, the deeper the water when it breaks. But if you see breaking waves, probably that means they're shallow water. So the wave height is from here to here, vertically. So when the depth is about equal to that, which is another one of these things that's easier to say than it is to do. And this is a shore break. This is usually when the beach is pretty steep and the wave, it gets shallow all of a sudden and it just breaks, bam, right on the beach. Really dangerous. A shore break, really dangerous. Kills people. Not good for paddling. This is wave interference. When different waves run into each other, they do crazy stuff. And I mean, like Carolina Beach Inlet, which you'll see a picture of where I paddle, it does crazy, and it looks like this. It does crazy stuff because you got waves from different directions hitting each other. Now, we tend to call it clapotis, which technically is scientifically has a little bit of a different definition, but this is what it is. Wave interference or clapotis. Like this, for example, here, when the waves are coming in and they're reflecting off of this seawall, waves will actually reflect just like a ball would. And so you have the waves coming in, then you have waves going out because they've reflected off the seawall, and you get like this. It gets kind of crazy. See, look at how this wave is breaking. It's breaking that way. It's like because this reflected wave is breaking and it's being interfered with by the incoming wave, which can create bigger waves or smaller waves or both, varying over time. Now, waves can reflect not just off of seawalls, they can reflect off of any hard man-made structure, but also even a steep beach, rocks, they can reflect off of. And I even think there's a little reflection sometimes by submerged rocks or steep areas, but I can't vouch for that. That's just a Warren theory based on what I see. So you got to be aware of the reflection of waves. They interfere with each other, and when they interfere, you can get chaos. So here is a phenomenon called refraction. Here, the waves, you can see the swell is coming in this direction, but look what happens. It bends towards the shore. And That's what these waves are doing. As the water gets shallower, the waves slow down. So this part of the wave slows down, but out here it's not as shallow, so it's going faster. So the waves tend to bend towards the shore. Now look here, look at the waves are coming at this way, quite a different angle than when they were coming this way. So waves will tend to attack and be stronger in projecting areas of land. And so that's something to be aware of. They will tend to be stronger there and less strong here, where they're kind of sheltered by this projecting land, which is good to know. If you need to land your boat, you may want to come to an area where the waves are not as strong. That's refraction, bending. Now, they could also refract even from underwater stuff that you don't see. And that's why your inlets often, our East Coast inlets, are chaos. For instance, here, this is interference. You have this wave coming this way, obviously from left to right. You have these other waves, I guess, probably coming in this way. It looks like from the ocean. Look what happens when they meet. Very steep. Probably wouldn't want to be in your boat up here. And it gets worse than this. I couldn't get good pictures of it, but what we're going to look at in a minute, Carolina Beach Inlet, gets worse than this, a lot worse. And I don't go there. I watch. I stay off here and look at it. Oh, here we are. This, we're going to hopefully answer that question that was asked earlier. This is Carolina Beach Inlet. I paddle here all the time. And this is gentle. This is like on its lamb day. Remember we talked about how the currents carry sand and sediment out, and then when they slow down, they drop it. That's why you have shallower water out here and in a complex pattern. So you have shallow water here. And so look at all the breaking waves. And as we've said, it's surprising how much bigger they look when you're in your kayak than they look in this aerial picture. And so this is chaos happens because they're not only breaking here, they're also bending. Remember, we talked about that refraction. So they can reflect off of these beaches sometimes. They refract and bend around here. They interfere with each other. Boat wakes come in here and stir it up. The channel does this. And so you just kind of got to apply everything we've been talking about to try to figure what's going on at your local friendly East Coast sandy inlet. This is a treacherous inlet. Boaters have been killed here. They get out here, they get swamped, they try to turn around. Oh my gosh, it's too big for me. So I guess answering that question earlier, which I think was something to the effect of what do you look out for? The main thing you look out for is white stuff. If it's white stuff, don't go there. It's breaking waves. And so even if it's not white, when you start to see the waves peak up like this, that means it's shallower. So it's not always, I mean, obviously it gets deeper the farther you go from shore, but that's not a completely regular pattern because of the sediment. And then you have the longshore currents taking sediment with them that have built this bar here. All this stuff is going on at once. All these things about wind, tide, and current and all that, they're all happening at once and they interact with each other. But that's what to look out for is steeper waves, breaking waves, changes in the color of the water. You can usually see shallower water by the color. And you can paddle out in this inlet and be in deep water. And then the next thing you know, you're someplace and your paddle will be hitting the bottom. It changes a lot. And I call this area the witch's cauldron because sometimes that clapatus can happen here like on mega steroids. I don't go in it. I stay out here and watch. And, you know, it's complex. The tide can be strong. The current can be strong through here. You just sort of have to try to relate to everything at once. But I think the answer to your question, and even let's say if you're out in the ocean, you will often want to stay somewhat offshore because the waves won't be as big there because it's deeper. And remember, the waves get built up when they get into shallower water. So the waves in here are going to be generally bigger than the waves out here. Another thing, staying out of trouble. remember that the wave you're in may not be the biggest one that comes along. When they say, when the surf report or the marine weather report says waves to 5 feet, that means the average is 5 feet. That doesn't mean there's not a 6-footer or an 8-footer or a 10-footer that comes along every once in a while, because they do. So you generally kind of want to stay a little, give yourself a safety margin, because where you are may be just fine until a bigger wave comes along. And now that wave will break where the other ones don't. So do that to stay out of trouble. Look for white stuff, look for build-up waves, stay in deep water if you can, and look for the buoys. Now, you can't see them here, but this is actually a marked channel, red right returning. In fact, that's where that red buoy was we looked at earlier, number 8 buoy, which is way in here somewhere. And then the C buoy is out here, the safe water buoy. And so if you see the red and green buoys, that's the channel, which is hopefully maintained and dredged by the Army Corps of Engineers, and they struggle to maintain this inlet because this inlet is not natural. It was created in the 50s or 60s, I keep forgetting, by the hand of man. It was dredged and then explosions. And so the ocean and this inlet have never really reached a peace treaty with each other, and the ocean keeps rearranging it. And so the Army has a heck of a time keeping up with the dredging, and then the Coast Guard has to come out and the Bayberry comes up from Oak Island to move the buoys, and out here somewhere is the sea buoy. So if you look for the red and green buoys, that's where you want to go. You want to go in the deeper water. And I have actually been out here, like kind of go on a falling tide, maybe. I won't go here usually if the tide's falling, because I don't want to, like, if I fall out of my boat, I don't want to end up like in Africa. You know, I'd rather end up back in North Carolina. But sometimes I'll take, like, if we're getting near the end of the low tide cycle, I'll ride that low tide or maybe ebb tide, no flow out, and then come in on a rising tide. But I've actually been out here and have waves breaking all the way across the whole channel, red to green buoy, waves breaking. And I said, I'm not coming in that. And I've actually messed around and paddled around for like an hour out here, knowing that the tide is rising about 8 inches every hour. And therefore, after half an hour, it's a little bit deeper and a little bit less risky to come in. Deep is good. So it's kind of like you got to put everything together. I hope I answered that earlier question about what to look out for. Let's see if I can get this out of the way here. Oh, anyway. Typical of our East Coast sandy inlets. Yeah, true. This, yeah.
Warren, is that the end of your presentation?
No, but we're getting near the end. Are we at the end of our time?
No, we're good.
We've got a couple more slides. We're getting near the end.
Okay.
Okay, so boom, Carolina Beach Inlet. This is Frying Pan Shoals. This is Cape Fear, the infamous Cape Fear. So Frying Pan Shoals, look, this is like 20 miles out. And look what's going on, breaking waves because of all the sand. You can even see it. So if all the sediment gets carried down here, it gets deposited and creates shallows out here. So this is like, you know, the whole graveyard of the Atlantic kind of thing, you know, like bad news. So beware waves, a lot of energy. Like, do you want to be paddling out in this? Okay, well, that's not too bad. What about when you get here? Okay, anybody have any guess where this is? Well, I don't think you could conceivably guess because I sure couldn't. This is not the ocean. This is a river. This is what's called the tidal bore. This is just like for interest. We're never going to worry about that. But actually, due to the rising tide, the water does something strange and can form breaking waves in rivers. And there are actually people who surf in the Amazon River and in other rivers far from the ocean, where actually you go to the ocean and there's no waves in the river, but farther upriver, well inland, the concentration of water as the river narrows, as the tide comes up, creates a tidal bore. And there are actually people that will surf on the tidal bore. You'll never need to know that. Okay, so this is just some sources of information. A couple really great books, all about the tides, all about waves and beaches. This is a pretty old book. You could get books of tide tables. My Tide app on your phone. I get this, tells you wherever you are in the United States, they'll show you a little map. You can click on something to find out what the tides are doing. You can get marine weather on your VHF radio. If the app is still working, which it still works, you can go to NOAA buoys and see what's going on with the wind and waves, and sometimes water temperature, depending on the buoy. There's all kinds of different places, the NOAA Weather Service, tides and currents, U.S. harbors. There's like a bazillion sources of information about tides and weather. So that is the end of the presentation. So I know I've been doing all the talking. Does anybody have any comments or questions?
Do we have any questions? Warren, I think that was fabulous. I think just the breadth of information that you put in there with your illustrations, and I think your experience on the water, I think it's really been really good stuff. Yeah, go ahead.
We have a question.
Yeah, it's more of a comment. I'm in Flotilla 10-1 with Warren, and I think what Warren's laid out is really important. It really for me, what it does is make me think about mission planning. It makes me think about, okay, you're planning a mission, you've got this tide situation, you've got wind, you've got all these factors playing into, your situation that you're going to be encountering. And it's, how do you plan so that your second half of your patrol is favorable to you? And I think that's really important because safety is paramount. And so you think about all these things, maybe wind and tide isn't such a bad thing if it's the latter half of your patrol and it's helping you get back to your starting point. Because you certainly don't want to get in a situation where you plan a patrol, you get out there, and then you're fighting all of these factors getting back, because that's the worst case scenario. So Warren, thank you.
Thank you, Glenn.
And I think in Oxpad, we do have some pretty tight constraints on the kinds of conditions we're allowed to be in, which is good. But some of us end up going out in conditions that are beyond the Oxpad limits. So I think it's good for us to be thinking about that in those other outings as well. Any other
Oh,
comments?
yeah, I forgot about that part. Yeah. Don't do as Roland says, as the book says. Don't do as I do. Do like the book says.
Yeah, just one comment. Look, folks, remember that when you're out on a mission, whether it be a mission or if you're just out paddling, remember, if the conditions change and they become more than what you're comfortable with, get off the water. End the mission, live to fight again another day. Safety is paramount. Anytime you're out on the water, I don't care if you're paddling, boating, whatever, swimming, it doesn't matter. If you're uncomfortable with what the changes are, then get off the water.
I've been down in Carolina Inlet with Warren in a class, and basically about 90% of the class had to get out of their kayaks and just walk it back, carry the kayaks. It just wasn't working out. That current was stronger than we were. So yeah, sometimes you have to just kind of slog through it. Well, thank you, Warren. That really was fabulous. And I think you've agreed to share your deck. So we'll make that available to people. I think it's good stuff. And thanks to everybody for joining us tonight.
Yeah, thank you, everybody, for being here. I've really enjoyed the presentations that some of you have done. So thank you for being here for this one.
Thank you. Good job.
Thanks, Warren.
Thank you all. Let's see.
Okay, I'm going to leave the meeting then.
Okay.
Unless you have something you want to talk about, Roland.
No, I was just looking for the end record.